Hey math lovers and haters. So in this video I'm going to be discussing the fundamentals of math. This includes tips for succeeding in fundamental mathematics and how you might be able to get these fundamentals in place to take difficult classes. I'll be providing some fundamental axioms and theorems for abstract algebra and analysis as background fodder while I discuss this topic. So when discussing the fundamentals of mathematics, starting from the beginning is the most important. For anyone to get into mathematics, they must be able to master arithmetic first. Now, most people do not have arithmetic issues, but there is a problem that people might have towards arithmetic. Mental math, while not a major component in high-level mathematics, is important for fast test taking. If you cannot do mental math to your best ability, then you will be resorted to using a calculator for tests. Depending on the type of teacher you may have, this may be a problem. For example, my Calc 2 and linear algebra professor did not allow calculators on almost all quizzes and exams, so if my mental and math abilities were not in check, then I might not have been able to complete quizzes under the 10-minute time limit. So in order to shore up your mental math, practice and tricks are key. For instance, make sure to have multiplication facts in your head to recall them easily and efficiently. So when someone asks you for 9 times 7, you'll know that it's 63 immediately. For higher multiplication numbers, paper and pencil might be needed for faster calculations, but if you don't know the basic multiplication facts from 1 to 9 within a second, it will take much longer for you to multiply large numbers. Towards tricks you might be able to use, a major trick in mental math is to ballpark estimates to check your answers. So take for instance 257 times 12. Now if I get an answer of 1254, then I can ballpark an answer by making the problem easier to mentally compute. So for 257 times 12, I can instead multiply 250 times 10, and that is a mentally computable answer of 2,500. So my answer of 1254 is quite wrong. So if you're able to practice and know tricks like ballparking, then you can more easily compute and check answer in high-level math contexts and tests and general life situations. Now, if you have your arithmetic down, then classes such as algebra hits, and you might have gotten a bad teacher. It happens to the best of us, so what can you do to move on to higher-level math classes without a hitch? Well, practice comes back again to help you in your time of need. But instead of practicing by yourself, it's better to have someone else help you that is more experienced in math, whether it be a friend, parent, or former teacher. This is more general advice towards helping shore up math holes you might have, so I won't mention it again in other sections. Another tip is to always show all of your work until you master the concept. It might seem stupid at first, but once you show your work, then it makes it much easier to figure out where your mistakes might have gone. Only once you have developed an ability to solve problems more effectively is when you're able to skip those minute steps. Through my experience tutoring, I've seen mistakes both big and small, but it's usually the small mistakes that more people run into. Let's look at an example of the spectrum of showing work. In box A, all of the work of the problem is being shown with clear indicators of the type of step being used. In box B, no step indicators are being used, so not all of the work is shown, but all steps are shown. In box C, a step was skipped entirely with no indicator of what happened in each step. Now box C might be enticing, but keep in mind that box C is only able to be fast and accurate when you master box A and box B. It is a spectrum of work, and if you skip steps and indicators without mastery of those concepts, then you will both struggle with getting the answer right, checking the answer, and being fast with the answer. For equation manipulation in algebra specifically, it can be a bog to show every step meticulously. Even I don't show every step in an algebra equation, but if I make a little mistake that throws my entire equation into chaos, then it can drastically affect my final answer. When you deal with equations like these, then you'll learn to realize that skimping on steps might seem like a bad idea. Now, you might have heard these things time and again, and you might have some qualms about how to implement these changes. You could be afraid of going into math again after you failed a class, or you might not have the resources to practice to the fullest extent. Towards being afraid of going into math again, a major hurdle in math classes is the grade. But if you take a casual approach with math, without a grade looming over your life, then it will help out so much in terms of bettering yourself. Without a grade, fear of mistakes ceases to exist. And now you can make those mistakes and learn from them. If the fear of math is so bad that you tremble just looking at it, always try to be with someone else when you do mathematics, and ease into it slowly but surely. With finding resources, if you can't find someone in your life to help you with math, then free online resources in mathematics can be a godsend. Although it's preferable to have someone in-person tutor, the internet has many specific topics to look at, so your specific problem can easily have an answer online. Now, if you have your fundamentals down through a good teacher or on your own time, congrats! Now you have to deal with harder math towards the end of schooling. Now, for tips on harder math, try the same methods previously, which are practice tricks and showing your work. Depending on what level you stop in math, though, you can either stop when the calculations get crazy or when you go into proofs. Let's talk about when calculations get crazy first. Most secondary school students either stop at a level right before calculus or calculus itself. Now, for the level right before calculus, you have to deal with both the hardest form of algebra and trigonometry. If you want to get to calculus, you'll have to learn exponential, logarithmic, and trigonometric functions fully. A major tip is to learn the rules of those functions inside and out in order to manipulate them. This means learning the exponent rules, logarithm rules, and trig identities. If you do not know these rules without looking them up, there will be no chance you can complete some of the more difficult problems, even if you're given a list of the rules. Luckily, when you learn exponent rules and logarithm rules, with an astute eye, you'll realize that the rules are inverses of each other. So multiplying e to the x by e to the x results in e to the x plus x, while the logarithm does the opposite, where two logs added together results in the inside of the log being multiplied. For trig identities, only 4 are technically needed, which is the inverse of sine, cosine, and tangent, along with the sine of x squared plus the cosine of x squared equal to 1. With these 4 identities, a lot of the other simple trig identities can be derived except for the double and half angle formulas. And what I did for calculus, I only used the half angle and double angle formulas for select few integration problems. Otherwise, manipulating trig functions only concerns those 4 basic properties. Now that you can learn these important concepts of functions, you can move on to calculus. With calculus, it's extremely difficult to derive certain simple derivatives like sine of x or the natural log of x, so don't bother trying to understand why those are the derivatives and just memorize them. If you want to get into the proofs, either as a minor or major in college, then it would be appropriate to see where those simple derivatives come from. Otherwise, just focus on the complicated functions and use the product, quotient, and chain rules with the simple derivatives to work with any kind of function. Towards integrals, they can be more difficult than derivatives, so just focus on the methods that will be taught to you in a typical class on integrals, including antiderivatives, U substitution, partial fractions, and integration by parts, just to name a few. If you decide to go farther into math and go into proof land, I have a couple of tips as a current college student on what to do towards proofs. Tip 1 is to not over-rely on the internet for proofs you may be doing. The best way to practice proofs in a setting like discrete math, abstract algebra, or analysis is to first complete the problems on your own, and if you struggle in an aspect of the problem, then try to use the knowledge from the internet to complete the proof. What you'll realize is if you don't practice your abilities on proof making and just rely on the internet, when you go into a test, you'll lose all knowledge on how to set proofs up and make them. So, practice proof methods like direct proof or proof by contrapositive, contradiction, cases, or induction. Also, a quick tip is to not use proof by contradiction unless you have to. Contrapositive can work in some cases that contradiction also works. In this video, I showed some simple proofs and what they can entail, but it only gets more complicated as more theorems are thrown around. Tip 2 is to ask for help if you have trouble. Math at this level is a collaborative subject, so talk with your peers or your professors on questions you might have, and if you're with peers and they don't know the answer, you can still work on it together to bounce off ideas. If you're an aspiring professor, teacher, or even general worker, consider this an easy way to gain practice for when you work on more creative projects after college. Those are just some of my tips and thoughts on the fundamentals of math and how to better yourself in mathematics. It's the summer, so if you're watching this now, maybe try to practice some math if you're struggling so you might be ready for the next school year. If you are in school, try not to panic. If you're too high over your head in math, there are resources out there to help you, either in person or online. I hope you enjoyed this video. I'll be taking suggestions as to what to do in the background for future videos in the comments or on Discord, so let me know what you might want to see. Thanks for watching.